Hello, my name is Renzo Mondaini. As you'll have seen from the title of this video, number 3, I'm going to present another low-energy cold fusion nuclear transmutation. Potassium minus oxygen equals sodium. This was another of Kervran's hypothetical experiments. I started with an electrolytic cell identical to the one seen in video number 1. A potassium carbonate solution and 2 copper electrodes at 12 volts. My main objective in video number 1 was to produce the crystals with a bluish liquid. For this reason, I tried to change the electrodes as soon as they became covered in oxides. I noticed that after about an hour the anode was covered with copper oxide. The copper oxides, as there were 2, one red and one black. As these oxides were produced, there was less production of the crystals. As the experiment continued, I realized that it turned back into being a normal electrolysis as bubbles were forming at the anode. So, approximately every hour, I changed the electrodes in order that the green crystals would be produced. I took the products of the reaction in video number 1 to a laboratory which had an ICP spectrometer. With this instrument you must specify which element you want to observe, and I only specified sulfur. For this reason I didn't realize that there were other transmutations in the electrolytic cell. This all changed when I went to another laboratory, a laboratory in the University of Bologna, and this laboratory has an AGX spectrometer. This spectrometer can do complete analysis of all the elements present in a sample. I carried out a second experiment in which I let the 2 electrodes react continuously for 3 days. As one of the electrodes, the anode, wears away and the cathode gets covered in deposits, I repeatedly inverted the power to the electrodes, so sometimes the anode became the cathode and the cathode became the anode. In this way, the electrodes basically cleaned themselves. I let the reaction go ahead by itself, so initially we got the green crystals and the blue substance in the liquid, and as time passed we got the formation of oxides, and the anode started to produce oxygen bubbles, and the cathode continually produced hydrogen bubbles. So I left this reaction of oxygen and hydrogen production for 3 days. Afterwards, I collected the liquid part and the solid part and took them to be analyzed in the University of Bologna. I couldn't believe my eyes when I got the results, as there was something amazing in them. There was no potassium present. There was sodium in its place. As for the liquid, I have a certificate which shows that the main constituent of this liquid is sodium at 5.14%, then copper at 0.2%, and sulfur at 0.06%. In the solid part, the main constituent is copper at 52.55%, then sodium at 7.93%, phosphorus at 0.04%, sulfur at 0.02%, and calcium at 0.03%. Naturally, I thought I hadn't carried out the experiment correctly, that I had mistakenly used kitchen sodium bicarbonate, which I sometimes use in experiments. So I decided to do a third experiment, identical to the second. Electrolysis that continues for several days, during which the anode and the cathode produce solid substances. as well as hydrogen and oxygen bubbles. Afterwards, I got the following analysis, which confirms that in the liquid part there really was transmutation of the potassium into sodium. In fact, there was shown to be only 0.11% potassium, while sodium was at 2.52%. There was also magnesium at 0.21%, copper 0.13%, silicon 0.03%, iron 0.01%, and sulfur 0.01%. The analysis of the solid part is slightly different to the previous one. Here there is both copper and potassium. Copper 24.71%, potassium 15.24%, but there was no sodium present. Sodium is only present dissolved in the liquid part. We also find other components like magnesium 0.03%, aluminium 0.09%, silicon 0.42%, phosphorus 0.01%, sulfur 0.01%, calcium 0.04%, iron 0.03%, and nickel 0.02%. Now I'll show you these certificates in detail. I'll start by showing you all of Kervran's hypothetical reactions. As you can see, there are only two which he considered to be two-way. This one and this one you can see from the symbol with the double arrow right and left. The experiments which I carried out were these. Oxygen plus oxygen equals sulfur, and the other is this. In fact, it's the inverse of this. Kervran had suggested that sodium plus oxygen would produce potassium. Instead, I carried out the inverse transmutation. I took oxygen from potassium to get sodium. Now I'll show you the certificate of analysis from the first video, number 1. This is for the liquid sample. As you can see, there's a total sulfur content of 6,800 milligrams per kilo. The value is so high because I let the liquid evaporate, and at the end there was less than 1 centimeter cubed of liquid and less than 1 centimeter cubed of solids. It was very concentrated, and that's why the values are so high. Some people found the values surprising. This is a certificate of the solid product. Total sulfur of 53,000 milligrams per kilo, as you can see. Now I'll show you the certificate of analysis of the second experiment, in which there was transmutation of potassium into sodium. In fact, as you can see in the liquid sample, the main component is sodium at 5.141%, then copper at 0.2%, and sulfur at 0.06%. We also have a table, a graph, which shows the sodium peak, while here, with the aid of the computer, we have shown the two bars, the two lines which should have appeared if there had been potassium present. But here below there are no potassium lines. Now let's have a look at the solid sample from the second experiment. We can see that it is mainly composed of copper 52.55%, sodium 7.93%, phosphorus 0.04%, sulfur 0.02%, calcium 0.03%. Here again we can see the two sodium peaks, and if there had been any potassium, there would have been two peaks here. Now I'll show you the certificate of analysis of the third experiment. Let's start with the liquid part. We can see that sodium is the main component of the solution, 2.52%, magnesium 0.21%, then there's copper 0.13%, potassium 0.11%, then we can see silicon at 0.03%, iron and sulfur at 0.01%. Now let's have a look at the solid part. The sample is composed mainly of copper at 24.71%. There is high potassium value here in the solid, 15.24%. There's also, and I can't explain why, silicon at 0.42%, plus other substances whose presence is quite unusual, like aluminium, 0.09%, magnesium 0.03%, calcium 0.04%, iron 0.03%, and nickel 0.02%. Then we have both phosphorus and sulfur at 0.01%.